Yep. Oh, shoot. Hold on. All right. Whoa, I'm a little dark there. Good morning, guys. How's it going with everybody?
Morning.
Super excited to see everyone. Oh, I see Yasmin, all smiles. I see Joshua De Leon, all smiles. Dennis Martinez, also all smiles. Actually, speaking of Dennis and Myra, I haven't had a chance to talk to you guys. How did that experience with Flinders Prep go? It went well? Myra?
I mean, it felt like a normal class. It felt pretty normal.
So kind of like the same as what we would do here? More or less? Okay then. Dennis, how was your experience? All right, not the talking type. All right, how about MacGregor? MacGregor, how was your experience with prep? Actually, I see some typing. Yeah, I was kind of with kids. Well, yeah, it's okay. That's it. I'm there. Figure that much. I know it's frustrating. For sure, it's frustrating. I'm glad Ariana's there. I mean, like I said, I'm glad that for those that went, I'm glad that you guys went, right? Because if you guys want to compete for those big top-notch schools, those kids are also competing for those top-notch schools. So, and those kids are, and I hate to say they're aiming for like 1,600, right? That's what they want. They want to get 1,600. So you got to shoot for the stars when it comes down to that stuff. So I'm certainly rooting for you guys. Kind of like how I'm rooting for you guys. The other kids, but did you participate, Myra? Oh, okay, well, hey, I'm glad you were. See, you took the initiative. And if you took the initiative, Myra, things went your way. I'm really glad you took the initiative. Just like MacGregor also took the initiative, right, MacGregor? Oh, okay. All right then. Okay. So, I found out the English teacher, Mr. Ferry, right? Really? He lives close. Lives close. Wow. What city does he live in? He lives in LA too? I know he has 2 kids, I think. I met his first kid a long time ago. Okay. That's crazy. That is a trip. Yeah, you haven't seen him, have you? I don't know if you've gone to that park and you've seen him. Have you seen him around, Mr. Ferry? Oh, have you gone out, Myra? Like, you've stepped out of your apartment, right? Because I go run, like, you haven't left? Okay, how about this? Let's have a conversation, right? Because I know Corona's affected all of us. Okay, for practice, that's one thing. But what's one thing that you guys have done? Like, have you guys gone out? Like, you guys have seen the sun, right? Hiking, okay, right? You can social distance. What's that, Blanca?
I went hiking too.
You went hiking as well? Okay. See, you can do stuff and not be cooped up in your apartment, right? Like, because I run every day on my street. You fell? Oh, Jasmine. What happened, Jasmine? What did you do? What did you do, Jasmine?
I slipped on a rock, and then there's like a cliff on the side.
Uh-huh.
And then I had to grab onto a tree. So I was just dangling.
Like, you weren't, like, you only saw, like, you were dangling. You just saw like nothing below you?
No,
It
I
must have
wasn't that far. Like, there's another trail right there, so like
Uh-huh.
it wasn't that far apart. Like I was able to like, how do you say it? Like grab myself, because my brother was there with me, so he had like all the equipment, but I just
Uh-huh.
happened to slip.
Ah, I see. Okay. So at least you had some sort of grip, right? To at least support you.
Yeah.
So well, I'm glad you came back in one piece, and I'm glad that you're here to learn calculus for us, because losing you we would certainly be losing a lot, Jasmine. I would agree. All right. You know what I also agree with? Your test on Monday. That's still happening no matter what. So I want to talk about real quick how your test is going to be laid out. Okay. So based on all the work, okay, so if I click on this and I click on your classwork, so I gave you guys a whole bunch of materials to work with, right? The the supplemental material for you guys to look at based on the descriptions. The Calculus for D workbook. Do you guys want the answer keys to both the Complete Idiot's Guide for Calculus and the Calculus for Dummies? Do you guys want those answer keys, yay or nay? Let me actually pull up, before you do that, let me pull up my screen to see everyone. Do you guys want me to put answer keys for these here? Okay, I'll put answer keys for those today. It is not homework, okay? It's for you guys to review. Okay, it's for you guys to review. I have not completely decided how I'm going to design this class. However, there will be quizzes, okay, and obviously tests after. I'm debating if I want to count homework. I'm not totally sure. Obviously, if you guys do well on the quizzes, that goes hand in hand. So I'm waiting until Wednesday to kind of like really figure out, do I want to count homework or not? Because I am counting quizzes and I am counting exams for sure, okay? So definitely keep that in mind for sure. Fun fact, I noticed that a lot of you guys, and you guys are the reason why, and I'm going to be blunt, you guys are the reason why I decided to make accounts for everybody, because I knew that was going to happen anyway, but you guys basically set the tone for me to make accounts, because I noticed like certain students, right, would take the quiz, they didn't like their grade, so they would take it again, they didn't like their grade, so they would take it again. So this means I made you all accounts, okay? So I made everyone accounts to use in order for you guys to access all of your quizzes and all of your exams, which means now I am in control of you, which means when you log in and you take the quiz, you cannot take it again, okay? Or if you take the test, you cannot take it again. Sorry, okay, in advance. All right, these are all the accounts you're using in the password. Oh, I see a chat. I want to see what this chat is. Let me see. I want to pop up. There we go. My name is spelled wrong. Did I not put a Z? Oh, all right, I will change it then. I'll delete that and I'll change it and I'll put a new one just for you, Jasmine. I thought I put a Z. My first name is, did I put Heidi? Already fourth day of school and I'm already embarrassing myself. How about this? All right, I'll change those later today, okay? But you're gonna need these anyway for Monday, so I'll make a new one for you guys later today. So I'll circle the names I need to change and Haiti. I'll do that for sure. Okay, so in order for you guys to access it, okay, if you want to change your pass, you can't change the username. You can change the password. Okay. In order for you guys to access anything that I give you guys, okay, you need to click on the link. So I haven't made anything for you guys yet, but let me do an example here. Let me do classwork and let me give a quiz that I gave for my third period class. Okay. If I click on view assignment, not that. Well, you know what I forgot to put? I forgot to put the link for that. I'm going to do that today. Okay, let's do this one for example. Okay, so let's do Jasmine's since we're not using hers anymore. So let's click on this. Let's click on this. Okay. So let's do Jasmine's because I'm gonna delete it pretty soon. That's not it. I want period 2 and boom. Okay, so your account is Jasmine Barcenas 520. Okay, so let's type that in. Jasmine Barcenas 520, and the password, I think it was East something, East 74. So East 74. I don't think you guys jurisdiction to do this. Notice how for this, you don't have access to that quiz because I've assigned it for specific classes, okay? So which means that you guys are going to have specific assignments for your specific class, and I control who gets to see what. Okay, so notice when I typed in Jasmine's account, she doesn't have access to it, or in any of your accounts, you don't have access to other people's stuff, okay, from other classes for that matter, okay? To answer your next question, I am making different versions for your tests, so I'm making 2 different versions. So some of you guys will have the same versions as your friends, some of you guys may not, but I'm making 2 different versions for sure, okay? As far as the test is concerned, we're not gonna have a Zoom session on Monday, but you have until Wednesday to finish your test. So Wednesday at midnight is when the test is due, and it's worth 100 points, okay? It's worth 100 points, okay? So that's how we're starting off the school year, okay? The stuff that I'm covering, okay, and it's mainly, well, I mean, this is gonna help you out for sure, the calculus for D and the CIG material, but more so the subject review, okay? I'll write this down for you guys, okay? So we're using HBC, okay? And I'm gonna lay out the exact same questions like what's it called? Like the book, okay? So 9 questions from chapters 1 through 4. Actually, I take it back, 1 through 5. 1 through 5, okay? So 9 questions from chapters 1 through 5. 1 question from chapter 6, okay? And then 5 questions from chapter 7 and 8. Okay, 5 questions from, if you guys want to write that down. 9 questions are going to come from chapters 1 through 5. 1 question are going to come from chapter 6. And then 5 questions are going to come from chapters 7 and 8. Okay, don't stress out too. The question from chapter 6 is going to be super straightforward. It's basically just going to say make an equation, right, from of an ellipse and all that fun stuff. Okay, it's gonna be pretty simple. So it's the stuff you guys did in Lamb's class, but I'm gonna make it very direct. Okay, the 5 questions from chapter 7 and 8, there are gonna be stuff that I'm gonna cross off that you're not gonna need to know how to do. So I'm gonna narrow that down. But pretty much everything else from chapters 1 through 5 are pretty much fair game. Okay, now if you want to do every problem out of there, that's fine. But I'm only choosing 9 of those questions, and I'm not going to tell you how much from what chapter, okay? Just understand how to do those from those 9 questions, okay? Like I said, on the AP exam, I don't know what's on the test, so you have to be ready for just about everything. But I'm at least telling you guys where I'm getting all my material from, okay? Are there any questions, comments, or concerns? Oakley dokley. Okay, so I know we left up on chapter 4. We're going to do the rest of it. Okay, we're basically going to do the rest of this here. So we're going to go now to chapter 5. Okay, we're going to look at chapter 5. Let's pull this up real quick. So many tabs. So many tabs. Goodness gracious. All right. Let's go to chapter 5, white box. So we're going to start off with 5-1. Now, if it says graph, we're not going to graph, right? It just seems pointless if we're graphing is going to be pretty much impossible, okay? But if I ask you guys to solve, that's a whole different case, okay? Solving for equations here, okay? So let's start off with 5-1, okay? You can use Desmos, right? If I ask you guys to graph, you guys can use Desmos for this, right? But do you guys understand how to graph anything? If you say no, I'm going to kick you out of my class. Like, for example, Josh is smiling, so I could just go remove and you're gone. Okay. All right, since he understands it, we're good. Domain and range. Do you guys understand domain and range? I know it's talked about seldomly. Do you guys understand domain and range? So if I give you guys a question like this, okay, let's draw a line. If I draw a graph like this, okay, 1, 2, 3, 4, put that 5, 1, 2, 3, and it's a parabola. Okay, and that vertex is 5, 3. Can anyone tell me the domain of this function? Either type it in the chat or you can say it. Either lagging Myra or anybody else. Why is the chat not coming up? Goodness gracious, I'll figure it out later. Can anyone say what the answer would be for domain for this particular graph? No one can.
Myra typed it in.
Oh, you did? How come I can't see it? Where is my, let me,
It said negative infinity to positive infinity.
yes, very good. I just couldn't see the chat. I don't know why I wasn't pulling up. So let me actually pull up the chat. Let me share my screen again. That is so strange. Let's try this again. There we go. Found it. Okay. And what I'm going to also do, let me actually do some readjusting real quick. I'm going to minimize this. I'm going to pull up you guys again. And boom, you're all there. Okay. Yes, it's all real numbers. Okay. Excuse the typos. Yeah, it's all real numbers. And we're going to write it in interval notation, negative infinity to infinity. Okay. Obviously, if I give you guys a question like this on the test, you're going to write negative inf or infinity to inf or infinity. Okay. That way I can see that you guys wrote down infinity. Okay. How about the range though? Okay. Range are all the possible answers. What's our smallest answer?
3.
3. And what's our biggest answer?
Infinity.
Very good. And thank you, Myra, for writing an interval notation as well. 3, comma, inf, and then you have a hard bracket because you are including 3. Okay, that's very important. Let's do one more. Let's do one more. Okay. Beep, bop, and then beep. And let's say I draw a straight line, but there's a hole at 1. Every x gives me an answer except for what? Every x in this line gives me an answer except for what? Whatever the coordinate is, okay? Yes, whatever. So notice how I've got an open hole right here. So yes, let's actually use that context, Myra, right there. At that point, nothing exists. There's a hole there, right? So what x value does not give me an answer?
2.
Yes. Anything else does. So I can say negative infinity to 2, and then from 2 to infinity. And the reason why I have to write it twice is because there's a break at 2. So at 2, I'm saying that the answers don't exist. For the range, same thing. What answer doesn't exist?
1.
Very good. Negative infinity to 1, and then 1 to infinity. See, you don't even need me here physically to help you. You guys have an understanding. I can teach you wherever I'm at, right? You're at home, but I'm still yelling at you guys about math. It doesn't matter. How about that? Okay, so now let's talk about domain and range for an exponential function, okay? If you guys, this is actually important, so please copy this down. I think there's a high chance I might ask you guys a question like this, where I give you guys a random graph and you gotta give me domain and range in interval notation. That might come up for sure. I got a feeling it might. I'm not decided. I've not made your test yet. Okay, just a heads up. Okay, so let's talk about domain and range for an exponential function. Whoop, just like that, okay? Does every x give me an answer? I feel like every x gives me an answer, right? Though, yes, they are gorgeous lines, yes. Very gorgeous lines. So we can say the domain is negative infinity to infinity, okay? But now the range, okay? Now, Myra, you're saying this is basic, that's true, but believe it or not, domain and range is actually very difficult for a lot of people, okay? It boggles my mind that kids don't understand domain and range, even when they look at a graph. Okay, and if you guys aren't you guys aren't the only ones. If you guys find it a little confusing, because it happens across the world, believe it or not. For the range, okay, what answers don't exist? In this particular graph, what answers don't exist? Negatives. Also, what does not exist? Because notice right here, this graph is never, yes, it's never going to cross the x-axis. So I can say 0 to infinity, but not including 0. Because 0 also does not give me an answer for an exponential function. So for any exponential function, a to the x, obviously domain's all real numbers, but then the range 0 doesn't exist, and anything less than 0 does not exist. So yes, MacGregor, it's 0 to infinity. Very good. Okay, so that covers domain and range there. Okay, that covers domain and range. All right, so now let's talk about logarithmic functions, which is 5-4. So log of b of x. Can anyone in one word, logarithmic functions are the bleh of exponential functions. Logarithmic functions are the brr of exponential functions.
The base?
No. Yes, Dennis, inverse. Inverse of exponential functions, very good. One more thing, by the way, the important point for the exponential, 0, 1. The important point for a logarithmic, it's 1, 0. And the graph is going to look like this. Like that. So now let's talk about domain and range. Every x is not giving an answer. So notice how the domain and range flips. The domain flips from the exponential to the inverse, 0 to infinity, not including 0. And then the range, it is from negative infinity to infinity. Okay, do you guys remember how to convert exponential to logarithmic? So if I give you guys y equals b to the power of x, and I want you guys to convert it to logarithmic, do you guys remember? X equals log of base b of y. Wait, yeah, of y, and y is not the exponent. Y is considered to be like the big part, so we'll just make that the big part. So let me actually delete that real quick. Log of base b of y. There we go, it looks a lot better. Yes, log base b, very good. So in other words, the way you convert it, base exponent answer. Base exponent answer. Base exponent answer. Base exponent answer. Okay, the way that you rewrite it. Okay, food for thought there. Okay, any questions on this? Oakley to Oakley. So we're gonna need this idea, by the way, to answer a lot of the other questions. Okay, so let's take a look back. We're gonna skip this here. These are some really important ones. Okay, and most of this will be mental. Okay, so 5, 5. If I ask you guys to solve this equation, log of base 10 of x equals 2, the way you can do it is you can rewrite it exponentially. Okay, so let's fill in the blanks. Brr, that's not what I wanted to do. Brr, brr equals brr. So what is the first brr? Actually, Myra, you got it. 10 squared equals x. Very good. Okay, so that means x equals 100. Got it. Okay, same thing for 5, 6. Right? Let's rewrite this exponentially. Brr, brr equals brr. Type it in the chat, or you can tell it to me. Four to the power of negative 3 equals x. Very good. So 4, negative 3 equals x. What is the answer? The answer is not negative. It is a fraction. Can anyone tell me off the top of their heads? Very quickly. Very good. And the reason why it's 1 over 64, in case you guys forgot, because I saw a lot of confused faces. Thank you, Jasmine, as well. Remember, there's no such thing as negative exponents. So you bring it to the bottom, put a 1 on the top. Boom, that's why you got 1 over 64. Smiley faces for everyone, including Shirley. Because I like to see Shirley smile. Where's Shirley? No, you're not smiling? Is it because you have me as a teacher? Is that why you're not smiling? You're thinking, I'm wasting an hour with Nunez. I could be doing other things. Right, Shirley? Exactly. All right, moving on. Okay, we're going to skip 5. Actually, 5, 7, that goes hand in hand. 5, 8, pretty much the same thing. Yeah, pretty much the same thing, more or less. Let's talk about 5, 9, though. She could be with Lim instead. Yeah, that's true, but then I decided to take over the class this year. So sorry, Shirley. But sorry, not sorry. Let's talk about now number 5, 9, okay? We're still doing this mentally, okay? Burp, burp equals burp. And it's gonna be x to the second equals 16. We need to figure out the base. When I square it, it's 16. Mentally, what is it? Good job, Joshua. I saw you mouth the number 4.
Yeah,
so
my
therefore,
bad.
No, it's fine because you did say it correctly. X equals 4. Okay, x equals 4. 5, 10's a little fun. I like 5, 10. Okay, let's check this out. X to the power of 4 over 3 equals 81. We can do this mentally. What I want to do first is this. I want to get rid of that 4 on the top. What is the reciprocal of 4? It is a fraction. When I talk about reciprocals, I flip it. Good job, Myra. 1 over 4. So that means I'm going to raise everything to the power of 1 over 4. And the reason why I'm doing that is because I want to cancel the 4. Boop, boop. That goes bye-bye. So now I've got x to the power of 1 over 3. But now this also becomes 81 to the power of 1 over 4. Okay? So this means I need 4 of the same number to give me 81. So it's got to be the same number. Blurp, 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 blurp equals 81.
3.
3, very good. So it is going to be 3. So that means 81 to the 1/4 is going to be 3. Now I want to get rid of that 1/3. I need to find the reciprocal now of 1/3. So what is the reciprocal of 1/3? 3, very good. Okay, so that means x is going to be 3 to the 3rd, which is going to be 27. Boop, there you go. Okay, any questions on 510?
Why was it? Oh, never mind. Just kidding.
Okay. All right, so you're good, Miguel. Any other questions? Okay, anything that says sketch the graph or graph without a calculator, we're not going to focus on that. We're going to skip the graphing part of this, okay, for the most part. I want to focus more on the algebraic techniques more than anything else, okay? So like 511, 512, you don't have to worry about that. So anything about graphing doesn't matter, okay? So let's move on now to the next part here. Natural and exponential logarithmic functions. Okay, remember, when we talk about natural, okay, 2 parts, ln of x and e to the x. Those 2 come up a lot. When it's logarithm, we're not talking about natural stuff, okay? So this all comes down from 513, right? 513 comes from the natural part of it, right? So ln of x and e to the x are the natural part of it, okay? 514 we're going to skip, 515 we're going to skip. If you guys don't know how to use a calculator, I don't know what to tell you, okay? I like 516 though. I'll give you guys a hint. I don't know if you guys remember how to do this. So log of base a of b, you can actually find it with a calculator. Log of b over log of a, okay? So the way that you can rewrite this, log of 25 over log of 3. And then you get your answer there, right? That's the exact answer. The approximate would be using your calculator. Let me ask you guys a question here. And this will be for a point extra credit. How about this? Log of x equals 3. Can anyone tell me what x is mentally for a point extra credit? Now for ln, it's, it's different because you're using base e, but for log, this is easy. It is 1,000, Blanca. Very good. For another point extra credit, Blanca, if there's no number here, notice how there's no base there. Blanca, for another point extra credit, what base do we always assume it is if there's no number there? Very good, Blanca. So you get 2 points extra credit for that. Okay, so I'll actually denote that there. Boom, boom. You'll see that in your grade later today. Okay, remember, in math, if you don't see numbers, we can make assumptions of what the numbers are. Okay, Dennis, good job. Jasmine, good job. But Blanca beat you to the punch. Okay, so remember, if there's no number there, assume it's base 10. Okay, very important, right? So the same goes for 517, 518. You're doing the same thing. You're basically finding out what the number is by using this idea, log of b over log of a, okay? So that's gonna cover a lot of that. Properties of logarithms, for sure, that's gonna come up, okay? Does this look familiar? Log of AB equals log of A plus log of B. Does that look familiar, yes or no? Thumbs up or thumbs down? Okay, good. Okay, and then for log of A over B, It is log of A minus log of B. Finally, if there's a number next to a logarithm, we can actually bring it to the top. Becomes an exponent. Does that look familiar? Trauma? No, it's not trauma. I like doing this because it's like a puzzle. Okay, it is like a puzzle. I'm going to ignore the 2. It's irrelevant. Let's focus on all of this. So notice how there's pluses in between all the logarithms. So we want to make it from 3 logarithms to 1 logarithm. How am I going to combine, since they're all pluses, how am I going to combine it into 1 logarithm? What operation? I'm going to go from addition to what? I'm going to go from addition to what? Yes, multiplication. Very good. So this means plus plus. Let's focus on this one first. Okay, so it's log. I'm going to ignore the 2 because it's irrelevant. So it's going to be 5x and then plus log of y, and then put all those together, log of 5xy. Voila. Next one here, notice how there's a parentheses over this. Let's do those first. Log of 3 minus log of 9x. And then let's put these together with division. So it's log of 3 over 9x. Voila. There you go.
Yeah, you forgot to put the base. For
I know for the 5, I told you I was going to ignore it because it's irrelevant. I just forgot. I know I could put a 2 there for the first one. That I understand, Blanca, but I appreciate you checking out for me, though. Appreciate it.
it was
I know, Myra, thank you. I even told you, Myra, that I was not going to put the 2 there because it's irrelevant. Even though, yes, in that particular question, it's base 2. But for the test, if I give you a question like this, there won't be a base. Exactly, bruh. Okay, any questions on this? Everyone looks super excited, like Heidi. Heidi's like, oh, man, another half hour of this? Oh, doggone it. Oh, it's gonna be torture, utter torture. All right, moving on. Same thing for this. We're going to skip this one. Let me see 523. We can skip 523. We can skip that. Let's do 525. Okay. So for this one here, if I want to expand it into as many logarithms or natural logs as possible, notice this here. They're together. If they're together, I can expand it with 2 natural logs using one operation. And that is the answer. So what Myra did is she used addition to split it. Okay, so we're going to go ln of x plus ln of y squared. And again, notice how there's an exponent there. We can bring that to the bottom. Okay, so it's going to be ln of x plus 2 ln of y. Okay, and that would be your expanded part there. Any questions on 525? Okay, I'm gonna move on here. So let's keep going. We're gonna skip the other stuff because that's, that kind of goes hand in hand. Let's start now with 528. This one's easy. Can anyone tell me what the answer is? It's actually right in front of you. If you have or have not done it.
3.
It is 3, right? Because the thing is if I drop that 3 down, it's 3 log a base 4 of 4, but this all becomes 1. So it's 3. There you go. Simple, easy, to the point. Okay. Same thing with this one. Okay. If you have a base and the base is the same with the logarithm, it's just going to be x, or whatever is inside the logarithm for that matter. So therefore, it's just going to be x. Okay. Any questions on that? Okay. So for this one here, oh, one more thing. For this one here, let's actually do this very quickly. For when I combine this, it's ln of e to the 4 plus 5x. Okay, because remember, if it's the same base, we add them. I'm going to drop the exponent. Okay, ln of e. What does ln of e become? ln of e always becomes what? It's a number, guys. ln of e is always what? Very good, McGregor. It's 1. So this becomes 1. So that means it simplifies to 4 plus 5x. Very good. Got it. Okay. One other thing. ln of 1. ln of 1 is what? Those are two, for natural logarithms, those are 2 things you need to know right off the top of your head. Like you should spit it out automatically. So ln of e is automatically 1. And then ln of 1 is what? Exactly, Blanca. Thank you. It's 0. It's 0. Very good, Ariana, as well. Those are 2 things. If you didn't learn anything about natural logarithms, those are 2 things that you should definitely take out from Mr. Lamb's class last year. ln of 1 is 0. ln of e is always going to be 1. Okay, for the sake of argument. Okay. So if we look at now the next page, okay, because this is now where we need to learn how to solve. Okay, 531 kind of goes hand in hand. I'm not going to explain that one. Okay. Oh, actually, yeah, e to the ln of x becomes just whatever's inside. So if it's e to the ln of whatever, everything goes away except for whatever's inside the ln. Just a heads up. I do want to talk about 532 though. Okay. So 2 to the power of x equals 9. And I'm actually going to put a space right here. Because in order for me to solve this, I need to get x by itself. I want to find the exact answer, but I need to use the logarithmic properties in order to get x by itself. So what am I going to attach on both sides in order for me to start the process to get x by itself?
Wouldn't you use log in the base 2?
Exactly. Well, not log of base 2, just log. I can just use log, okay? So if I attach a log to both sides, what happens to the x? It's gonna come down. So that means it now becomes x log of 2 equals log of 9. Remember that log of 2 and log of 9 are numbers, okay? Even though there's a word next to the 2 and the 9, it's a numerical value. If you type it in your calculator, it spits out a number. So to get x by itself, I'm dividing both sides by what? To get x by itself. Exactly, log of 2, okay? So log of 2, oh, actually, log of 9 on the top and then log of 2 on the bottom. There you go. And I don't want the decimal, I want the exact answer. Notice how I was looking for the exact solution. That number there is the exact number. If I want to find the approximate number, I would use my calculator, type it the way it looks, and then it would spit out the approximate answer, okay? So now let's skip 533. Let's actually go to 534, okay? 533, I'll let you guys look at it on your own. In order to get x by itself, I need to attach an ln to the e, but for this one, it's a little bit different. So let's actually walk through this real quick. Before I even attach anything, okay, I need to get the ln by itself. So the first thing I'm going to do is subtract the 5, okay? So I have ln of x plus 3 is equal to 2. I want to turn these now into exponents in order for me to get rid of the ln. What am I attaching to the bottom of both the left and the right to get rid of the ln? What letter?
E.
Very good. I'm going to attach an e to both sides. Boop and boop. So now this becomes e squared on the right side. The left side, it's x plus 3. To get x by itself, all I got to do is subtract 3. Voila, you're done. That's it. And that's the exact answer. Exact answer. I'm going to skip 530. No, actually, should we do that? Yeah, I'm going to skip 536 because I used the quadratic formula. We're not going to worry about that. I do want to talk about 535. That's pretty simple. So we're going to skip those two for the sake of argument. Okay, any questions on chapter 5? Okay, I want to look at 536, and I'm for sure going to ask you guys one question, but I'm only going to do one question out of these, okay? Only one question out of these, okay? Because I do want to save Actually, you know what? I'm going to skip chapter. You're going to be responsible for it. You have to know how to complete the square. Okay, so follow the work on how to complete the square, because I do want to talk about chapters 7 and 8 a lot. Okay, so let's actually look at 7 and 8. Okay, looking at chapter 7, you guys understand how to convert radians to degrees and degrees to radians, right? If I want to, what am I going to use to convert radians to degrees? What numerical value? You can say it or write it. No, all the way around, pi over 180. So for radians to convert to radians, it's going to be pi over 180. And the reason why is because I want pi in the number for radians, okay? Which means to go from radians to degrees, this is going to be 180 over pi, okay? I need 180 over pi. So for radians, there's a pi in the number. For degrees, there's no pi, okay? So that covers 7.1 through 7.4. Okay. Let's talk about the next part here. Okay. Let's talk about revolutions before I move forward. Okay. Revolutions. Okay. For degrees, how many degrees are in a revolution? 360, right? Because it's a full rotation. So I'm going to divide 900 by 360. Okay. However, for radians, how many radians are in one revolution? It is also a numerical value. This also comes from your unit circle. I'll give you a hint. There's a pi next to the number. Very good, Jasmine, 2 pi. 2 pi is a full revolution. It's a full rotation, okay? And then for this one, you're going to divide it by 2 pi to determine the number of revolutions, okay? I'm going to skip complement and supplements. If I ask you that, you might be responsible for it, because I want to go now into 715, okay? And this is where it's going to separate the men from the boys, okay? The women from the girls, all right? The unit circle. I'm not sure how obviously no one knows how this AP test is going to be, but if you're asked to find sine or cosine or tangent of whatever, you need to spit it right out of your mouth, okay? I'm going to teach you guys yeah, exactly, Myra. I'm going to teach you guys the Nunez way on how to find, what's it called? The angle of anything if you're given any part for the unit circle, okay? So sine of pi over 2, for example, okay? Well, sine of pi over 2 is sine of 90. Does anyone remember this? All students take calculus. Did Mr. Lamb show you this? Or have you guys seen this before? No, that's concerning. Okay, so for this one here, all of them are positive. Okay, all sine, cosine, and tangent are positive. Here, sine is positive, but cosine and tangent are negative. Okay, here, tangent is positive, but sine and cosine are negative. Whereas in the last quadrant, cosine's positive, and then sine and tangent are negative. Okay, so sine and tangent are negative. So for sine of 90 degrees, we know it's if I draw a quick coordinate, right? It's right here, and that coordinate right here is going to be 0, 1. Don't forget that cosine is the first coordinate, sine is the second coordinate, so therefore sine of 90 is equal to 1. Okay. So yes, so I like to use acronyms like this because if I teach it to you guys mathematically, game over. But if I learn acronyms and I find it useful, I'll show you guys the acronyms, and I feel like it's a lot more useful because it's more so making it fun, and it's also more so having a grasp of what we're doing. Okay, so let's look at this. Okay, 7 pi over 6. Okay, 7 pi over 6. Let's convert this into an angle. Okay, 7 pi over 6. I'm going to multiply this by 180 over pi. Okay, that cancels. This becomes 30. That becomes 210. So the angle that I'm working with is 210 degrees. Okay, again, if you don't have the unit circle memorized, that's fine because we're going to use the Nunez way on how to find it. Okay, 210 degrees. What quadrant is 210 degrees in? We have 1, 2, 3, and 4. What quadrant is 210? I see Myra like playing the robot. Anyone else? We have 1, 2, 3, and 4. So this is 1, 2, 3, and 4. Yes, Joshua, it is quadrant 3. Very good. So let's draw 210. Okay, so it's going to go like that, 210 degrees. Okay, notice also how this angle here is 180 plus how much more? It's going to be 30 more. So let's think about the type of triangle. I'm going to zoom in. Let's think about the type of triangle I'm going to draw. If that's 30 and I draw a line right here, what kind of triangle am I going to draw? It's a 3-numbered, 3-angle type of triangle. 30, 60, 90. Very good. So this is 30, this is 60, and that's a right angle. Remember that always opposite of 30 is going to be 1, and since it's below the x-axis, it's -1. Okay, opposite 60, it's radical 3, and that's negative. Your hypotenuse is always going to be positive, and in this case, it's going to be 2. Cosine. What makes cosine? So we're using this. Not the numbers, but from the triangle, what 2 parts of the triangle make cosine? Remember SOHCAHTOA, guys. SOHCAHTOA. So ka, what is ka? That is correct, but I'm asking and thank you for giving me the answer. I'm asking for you guys to tell me how to make cosine from any part of any triangle. So it's cosine equals bleh over bleh.
Adjacent over hypotenuse.
Thank you, adjacent over hypotenuse. So this is the adjacent side, this is the hypotenuse. So therefore, from that angle. So this means, if I can move that over, come on, you zoom out a little bit more. Come on, show up. Show up. Okay, we can just say cosine. I don't know if you guys can see. I can decide to. It's stacked up right now, doesn't it? No, maybe not. Maybe so. You got a lot of what is going on here. Okay, it doesn't want me to leave. I'm going to stay. There we go. Okay, so we can say, there we go. It fixed itself. Cosine. Okay. Black magic, yes. Any questions on this? Okay. I do also want to go over 7-27 because this goes in context with this. So let's go to 7-27 real quick. This is actually one of my favorite questions, as a matter of fact. Okay. I know I lagged out. I apologize, Shirley. My internet, I don't know why, is being very unstable. Okay. Here we go. If sine of theta is -2/9 and tangent's positive, we need to find secant of theta. So we're going to actually go over 2 more things and then we'll be done for the day. Here's the thing, okay? Sine is positive. Tangent is positive. Oh, wait, no. Sine is negative. Wow. I'm not bright there. Sine's negative, tangent's positive. Now, here's the thing. It's either one of them are positive or all of them are positive. So if sine is negative, tangent's positive, that makes cosine what also? It's one positive or all positive. So tangent's already positive. So if sine's negative, that means, yes, it's going to be negative as well. So we need to think about what quadrant this is going to be in. So I'm going to actually draw this again for you guys. Okay, the all students take calculus. What quadrant is this going to be in based on this information?
3.
3. Very good. Okay, so I'm going to draw my triangle. Okay, remember that also that your what's it called? Your Hypotenuse is always positive, okay? So sine is negative 2 over 9, then 9 is the hypotenuse. The 2 is going to be negative. How do I find this missing side? What theorem do I use to find that missing side?
Pythagorean theorem.
Exactly, Pythagorean theorem, very good. So we're going to go 9 squared equals negative 2 squared plus b squared, okay? 81 equals 4 plus b squared. I'm going to cut to the chase. It's the square root of 77. So we need to find secant of theta, okay? Remember that secant, like anything of theta, it's a fraction. It's equal to a fraction. So notice how this was equal to a fraction,
You
okay?
forgot the negative sign for the square root of 77.
Oh, wow. You get another extra credit point, Blanca. Thank you. Anytime I make a mistake, then and I didn't mean to make that mistake, you get another extra credit point for anybody. So catch me on my mistakes. Thank you, Blanca. Remember that anything equal to a trig is equal to a fraction, okay? If we're looking for the angle, then we use the inverse. So with that being said, what's the reciprocal of secant? When we think of secant, what comes to mind?
Cosine.
Yes. So let's find cosine of this first. Okay. Remember, cosecant sine, and then cotangent's tangent, right? So what's the fraction that's going to make cosine?
Adjacent and hypotenuse.
Exactly. So what side's the adjacent side of theta?
Negative 77. I mean, negative square root
yes.
of 77.
Yeah, exactly. Good. Negative radical 77 over 9. But now I need to find secant, right? So that means secant, I just flip it. It's going to be 9 over negative radical 77. And you can leave it like that if you want, or if you want to put the radical on the top, it would be negative 9 radical 77 over 77. Same thing, pretty much. Okay. Any questions on this? Because for sure that is definitely going to come up for sure. I also want to talk about, actually we have time. Okay, we have time. 7-30, okay? 7-30. You don't have to. In my class, you don't have to, because this is the same as the other one. I know in Lamb's math, you don't have to, but in Nunez's math, and the reason why I'm saying that you don't have to is because on the AP calculus test, that's acceptable. Okay, it is acceptable. Okay, so it gives you the same number irregardless. So I'm not asking you guys to simplify completely. I do want to talk about 730 though, okay? Because this is where you need to mentally think about the unit circle, okay? So 730 and 731, okay? Our cosine, right? We now need to find the angle that makes this, okay? And I want to find it from 0 to pi. Okay, that's our interval. However, and that's for cosine. We need to figure out when it equals 1/2. If you haven't seen this, it's basic. Remember, our cosine is the inverse. So now I'm going to go from the exact answer to finding the radian value of it. Okay, so based on the unit circle, notice how the answer is negative. Since the answer is negative and it's from 0 to pi, what quadrant are we dealing with here? These are the two quadrants that we're dealing with. What quadrant am I dealing with? 1 or 2? 2. Very good. So it's somewhere in here. Okay. So we need to figure out when does it equal negative 1 over 2. Okay. So if I draw the triangle, okay, here's negative 1, here's 2. This means this angle is 30. That means this angle is 60. Okay. This means from here to here it's 120. So therefore, our cosine, 120, by the way, is 2 pi over 3. So that means our cosine of this is equal to 2 pi over 3. Let's do one more into context. Arc cosecant, which is this right here, okay? Notice how the answer is negative, okay? Meaning that I'm working with either quadrants 1 and 4. Since I'm working with a negative, it's going to be in quadrant 4, okay? However, let's focus on this. Cosecant, it's the reciprocal of what? Cosecant is a reciprocal of what?
CS. I forgot the freaking name.
Sine.
Sine. Very good. So cosecant, Blanca, is a reciprocal of sine. Yes, good job. Good job, Blanca. So notice how this is hypotenuse over opposite, right? So this means this will be radical 2. This is going to be -1. That's going to be +1. Remember that hypotenuse is always positive, okay? So this means the angle, it's 90, 80, 170, 270, and then 315. However, I'm going to go backwards though. So notice I'm actually going from here to here instead. It's going to be -pi/4. For the cosecant and tangent, it's going to be from pi/2 to -pi/2. Those are the intervals that we're working with here. Okay, any questions on I may ask you guys one question like this. I probably won't ask you guys a cosecant, but something more along the lines of 730. Okay, either arc cosine or arc sine. Okay, either arc cosine or arc sine. But you have to know where the answer is located. Okay, where the answer is located. I want to go over one part of chapter 8. Okay, and I want to talk about 8-22 before we're done for the day. Okay, here we go. Does everyone have all of this? Oakley dokley. I'm going to leave here. I can just reset this. Come on. There we go. Okay, let's talk about chapter 8, and I'm going to talk about 8-22. Okay, so beep, bop, boop, bop, beep, bop, beep, bop, boop. Did we get there? No, right here. Okay, you're looking for all the solutions between 0 and 2 pi of this function here. Your goal to solve for theta is to get what by itself? Obviously, we need to get theta by itself, but more specifically, what are we supposed to get by itself in order for me to figure out the answers? Besides getting theta by itself, we're supposed to get what by itself? The whole sine thing, basically sine. We want to get sine by itself. Very good. With the theta, obviously. So let's do that. I'm going to distribute the 3. Okay. So it's 3 sine of theta plus 3 equals sine of theta plus 4. Your goal right now is to get sine of theta by itself. Okay. So what I'm going to do is I'm going to move the sine of theta over here by subtraction. So now I'm going to have 2 sine theta plus 3 equals 4. Then I'm going to move the 3, 2 sine of theta equals 1. And then I'm going to divide by 2. Sine of theta equals 1 over 2. So now what happens here, okay, is in order for me to get rid of sine, does this look familiar? I'm going to take the inverse in order for me to get rid of sine. So now I've got theta. But now what I need to figure out is when does it equal 1/2? And this is where the unit circle comes into play. Okay. So notice how it's positive. It's going to be in the first and second quadrant, right? So here's 1 and 2. That's going to be 30. And 30 would be pi/6. Okay. And then here, that's going to be 30, 1, and then 2. 90 plus 60, that's going to be 150, which is going to be 5 pi/6. Okay, so the angle part of this, I'll just put it up here. This is 30 and 150. So if you want to find the angle first, then convert it, you can do that too. Okay, you're definitely in a way going to have to know how to do that part. Okay, it changes things a little. Actually, it's about the same thing. Yeah, we're good there. Okay. Any questions on 822? Because there's a good chance that that might come up. And if it does, just the interval from 0 to 2 pi. So you're not telling me every solution that there is. Okay, any questions? Okay, so like I said, anything that involves graphing, you're not responsible for, but anything you need to find algebraically, you do, okay? Chances are. I've got office hours today and tomorrow. Tomorrow I've got office hours till I think like 5 o'clock. If you want to just hit me up on Remind over the weekend to go over some stuff, we can do that for sure. But again, your test is on Monday at 11:10. 15 questions, like I told you, 9 from 1 through 5, 1 from 6, and then 5 from 7 and 8. Okay? And you have Monday, Tuesday, and Wednesday to do it. Okay? 75 minutes. And yes, I do upload the recording, so when we're done, I'm going to save the video, post it on YouTube, and then send you guys the link like I did for the first lecture. To answer your next question, yes, it is 15 questions, 75 minutes. 15 questions, 75 minutes. Okay? Any questions? I'll even cut you guys a little bit of a deal, but I'm not going to mention it till after the first test. Okay? I'll cut you guys a little bit of a deal because I know you haven't done math in a while, but the deal would be depending on how you do the rest of the semester with all of your tests. Okay? So we are officially done for the day. I'm rooting for all of you guys and everybody, rooting for everybody. So if you have any questions, hit me up on Remind, send me an email, send me a thing on Google Classroom. Let's get to it, guys. I'll see you guys on Monday.
Bye.
Can you
Yes, Blanca.
the recordings that you do, can you like post them on Google Classroom?
Yes. So once the video gets saved on my computer, then I'll post it on GC. And yes, there's a remind for the class. I did post the link on Google Classroom, MacRegor. Yes, perfect. All right, I will see you guys on Monday. There won't be a Zoom session. Basically, it'll be a link for your test. Okay, so I'll see you guys on Monday.
Bye. Stay safe. Have a good day, mister.
Bye.
Likewise, take care, guys. Stay safe. Appreciate the love.